I'm going to go ahead and go over this one. This is like what we were doing last week, and it's going to be very important that you understand and remember all these rules from last week because they're all going to be applying today. We're just going to add on a few more things. So if we are dividing, we have x divided by 2, or we can think of it as x divided by -2. The way we undo that is through multiplication. So we would multiply this side by -2. And on the other side, we would also multiply by -2. Now, because we multiplied by negative on both sides, that means that we need to reverse this sign. So instead of closing towards the 1, now it's going to close towards the other side. And remember, now we have x on that side because our -2's canceled out. And then 1 times -2 is just -2. Okay. Now, we talked about this a little bit, and I think you had some practice problems that went over this. But if we're graphing this inequality, the way that we're going to graph it, x is less than -2, is by shading in all of the points that are included or would be solutions. So if we're thinking about it, well, if x is less than -2, 2 itself, sorry, whoa, not 2, -2. -2 itself is not included in the solution because its x is less than -2. So if we have a less than sign, remember, that's an open circle, and that says that that's not part of the solution. And then we're going to shade everything that is a solution. So anything that would be less than 2 would be a solution. So this would be the way that we would graph this. An open circle on -2, and it would shade to the left. So if your variable is on the left side, the arrow always points to where you're going to be shading. Okay. All right. So like I said, this is a very, very important skill because you're going to need to use that to be able to solve these compound inequalities. Okay. So very good. Okay. So let's go ahead and get into the lesson for today. Okay, so compound inequalities. Like I said before, you're going to need to remember all the skills that we've kind of done in this unit leading up to where we're at right now. So all of those inverse operation skills are going to come into play. The difference between an equation and inequality. So remembering to reverse that sign if we multiply or divide both sides by a negative, that's going to come into play. Remembering the graphing thing. So where you have a greater than or a less than, that's an open circle. A greater than or equal to or a less than or equal to, that's a closed circle. So all of these things you're going to need to remember. Okay, so you should kind of already have these down in your notes, should already be in your brain, but these are all still going to apply today. Okay, so if you're like thinking about, well, what should I be taking notes on? Well, you know, these things should already be written down. So, you know, I don't necessarily expect all of these to be written again, but everything on this new slide is new. So everything in here should be written down if you're taking these notes, okay? So let's go ahead and talk about the two different types of compound inequalities. So all a compound inequality is just two inequalities put together, okay? And there's two ways that we can put those together. We can put them together with an and, literally the word and, or we can put them together with the word or. And the word that you choose to put them together has a big, big impact on the result. Okay, because when you use and, we're talking about the overlap of those inequalities. So the only numbers that would be solutions would be numbers that satisfy the first inequality and the second inequality. Okay, so if you're looking at this example, if we had x is greater than -2 and x is less than 3, we've got to think, okay, it's only the numbers that are already greater than -2, but then they also have to be less than 3. And there's a very specific set of numbers. Okay. Now, that's totally fine. Yeah, Melanie, you're totally good. So if we're looking at this problem here, let's talk about the number solutions first, and then we'll talk about the other way they can be written. So if the number has to be greater than -2 and less than 3, well, -1 would be one of those numbers, and 0 would be one of those numbers, and 1 would be one of those numbers, and 2 would be another of those numbers. But there's no other numbers that could be solutions, because remember, it has to satisfy both of those inequalities. Now, we could go all the way down to, 2.999, and that's where the number line is going to come into play. So if we were thinking about how we would graph this, well, x has to be greater than -2. So we would have this open circle at -2 and less than +3. And then remember, so these two numbers are not included, but all the numbers that are included in our solutions are the numbers between. Okay? So remember, and think of that as overlap. Okay? Now, the other thing that you need to understand is that an and inequality is usually not written with the word and. So when you see a compound inequality that's an and, chances are you're not going to see the word and. You're actually going to see it written with just one variable. And the reason you can do that is that you can sandwich it in between. So if you put your variable in between and you use less than signs, okay, so less than signs, we're saying that this variable has to be greater than the lowest number. Well, remember, this is saying x is greater than -2. So if we put -2 here, this part right here is this inequality. X is greater than -2. But this same x also has to be less than a +3. So another way that I could write that inequality, and more likely the way that you'll see it and the way that IXL is going to have you write them as your answers, is like this right here. Okay, so make sure you understand that. And this is how it's graphed. So and is overlap. Okay, now that's different than or. Okay, so or is outside. Okay, and yes. So Kwame, and is in between, and you're going to see exactly. So or is going to be outside. So when you see the word or, that's going to tell you that it only has to, so our solution only has to satisfy one of the inequalities or the other inequality. So it doesn't actually have to satisfy both of them at the same time. It can just be one or the other. And so for or inequalities, there's a lot more solutions than there are for and inequalities, because it can be one or the other. It does not have to be both. It could be both, that's fine, but it has to be one or the other. Okay, so let's look at this one. So if x has to be less than -2, or it has to be greater than 3. So let's think about it. Well, what are some numbers that are less than -2? Well, -3 is less than -2. What about -4? Sure. -5. So all of those, and so on and so forth, those would all be solutions. But those aren't the only solutions, okay? Because we also have all the solutions, or all those numbers that are greater than 3. So 4 would be a solution. 5 would be a solution. 6, and so on and so forth, okay? So all of those are going to be your solutions, okay? Exactly. So we would have to have definitely an open circle going to the left. So if we're looking at this, we have an open circle at -2, and that's going to be going to the left. That represents half of our possible solutions. But then the other half of the possible solutions, exactly. Yep, very good. So not at 4, but it would be at 3. Because at 3, remember, we're at greater than 3. So that would be all the solutions, 4, 5, 6, 7, 8, 9, 10. And so now we're saying, okay, remember, solutions are the shaded parts of your number line. So all of these numbers up here, and this goes on forever and ever and ever. And all of these numbers down here, and this goes in the negative direction forever and ever and ever. All of those are solutions. So the only ones that are not solutions are, -2 through +3. And then. Now, with the or, there's no way that you can write that as one with one variable. You have to use the two different variables, because we have the one side and then we have the other. The only reason that we can write the and with one variable is because there is this overlap here. So with or, you'll always see it written with two variables and two inequalities. Okay, so I want to make sure that everybody has this all written down. This is very, very important, because the rest of this lesson is just going to be going over example problems. But you really have to understand this concept. I think a lot of people get tripped up with writing these inequalities. So remember, these are less than signs that we're using. And as long as you use less than signs, then on this left side, it's going to be your lowest number. And on the right side, it would be the highest number. Yes. Yep. So the question was, with an or, if you have an or, when you're graphing it, are they always going to go out? And yes, unless there's a couple special cases, which is like the no solution and all real numbers. We're not going to talk about those. So for any of the regular cases, an or is outside. So you're always shading on the outside of those numbers. Good question. And an and is always going to be the overlap. All right, let's go ahead and move on to some examples. Okay, so these first examples, all we're going to do is try to come up with the actual inequality. And remember, if it's an and, Alex is going to want us to submit it or submit the answer with only one variable. So we can write it as two separate inequalities first, but then we're going to have to put it together as one big inequality. So let's look at this first one. This first one's an or. So it says a person aged, and that variable we're going to use, a person's age, A, so that's the variable we're going to use to define age, must be less than 12 or at least 65 to get the junior or senior discount. Okay, so if we're thinking about what type of inequality this is, well, it already says right here, or, so I know that I'm going to have the word or, and then I have two inequalities. Okay, so let's start with the first one. I think the first one is probably the easier one. A person's age must be less than 12. So that would just be A is less than 12. No problem. Okay, and then it says or at least 65. And this is where you have to remember all those translations from before. So at least is saying that it has to be that number or greater, which is a greater than or equal to. So on the other side of this, we would have A is greater than or equal to 65. And it's saying that if either one of these things are true, you will get the junior or senior discount, which makes sense. If you're less than 12 years old, which means you're 11, 10, 9, you should get the junior discount. If you're greater than or equal to 65, so 65, 66, 67, you should get the senior discount. So if you fall into one of those things on the outside, then you would get the discount. Okay? So that was kind of an easier one. Let's get into some of the ands, which I think are a little bit difficult. So the first thing that I always do with these problems is I always write them as separate inequalities, and then I'll put it together at the very end, okay? So the first inequality says is x is greater than -8. So we all know how to do that, x greater than -8. Alligator is eating the x because it's greater than, okay? So we've got x is greater than -8, and then the other side is saying, so and less than or equal to 6. So x is also less than or equal to 6. Okay. So if we're thinking about how we would write this as 1, well, remember, the x needs to go in the middle. And I always told you that if you use less than signs, you can always put the lower number on the left and the higher number on the right. So in this case here, we're going to use a less than, and we got to think, okay, well, one of these is going to have to be a less than or equal to. So if you're looking at your original inequalities here, this is pointing towards the x. This is pointing towards the x. So this is going to have my equal to underneath it, which means that my 6 is going to go here. And then on my other side, x is greater than -8 would go on that side. And this would be what we would have to write down. Yes, very good, Isaiah, very good. All right, so I'm gonna have you guys try this next one. So hopefully you understood this one. This next one, go ahead and try this out. So I'll start out with the regular inequalities, but I want you to give me the combined one. So W is less than or equal to 9. And then it says, and W is greater than 5. So go ahead, take a second here. Remember, to get your points today, you do need to participate. So Isaiah's already got it. Great work. Send me that in the private chat, your answer to this one right here. Okay, so when you're doing like the less than or equal to, like actually, I want the actual inequality. So like this right here. So less than or equal to, do this and then this. The underscore is a shift and then it's the number next to thing next to 0. Yep, very good, Amaya. Very good, Jair. Okay, so Makani, if you're looking at this one here, so we've got to write this, and we know it's an and, so we know that we can write this as one inequality. So we would write the W in the middle, and then the way I said this, and you've got to remember this, because this is the way it really, really helps you if you're having like a hard time remembering it. I always write it with less than signs. So some people are writing with greater than signs, that's fine. But I think it's easier if you write it with less than signs, because then this makes more sense. On this lower side, this is going to be your lower number, and this would be your higher number. So in this case here, you're thinking, okay, well, the higher number, that's going to be 9. And then because this is a less than or equal to, we would have to make this a less than or equal to. And then we would have the W, and then we would have less than. And then in this, the other side here, remember, the other side is 5. So 5 would have to be on our lower side. Okay. Again, this is just saying, okay, this W has to be greater than the lower number. Well, this W has to be greater than 5. That's what it says there. Let me go look. Yes, Siani, you are. But what I was saying is that on IXL, it's going to make you write it as an inequality with one variable. So you can't use the word and. You would just have to put that right in between. And so in this case here, you just put the W between. Remember, if you use less than, which here's a trick, the less than sign looks like your left hand. If you hold out your left hand, that is the less than sign. Left hand, less than. So if you use less than signs going across, then the left side is always the lower, the right side is always the higher. So if you flipped your inequality signs, so like Shania, you're fine. Like yours is the right answer. I just think it's easier to remember it the other way. So you wrote it as, well, W or 9 is greater than or equal to W, which is greater than 5. This is fine as well. I just think it's easier to do if you remember, because we always read from left to right in the United States. So I think it's easier, like if you're listing low to high, it makes more sense to go with less than sign. But again, this is a correct answer. So if you wrote it like this would be accepted, as long as you have a 9 over here, the greater than or equal to sign is on that side, and the 5 is on the other side. Well, the order only matters when with your inequality sign. So like I said, these are both correct answers. These are both. So if you have either this order with greater than signs or this order with less than signs, then you're good. But let's say if you had 9 and 5 and you had less than signs, then no, that would be wrong. So these two answers are good, and like I said, either of those would be accepted as long as you have it like that. All right. So let's go ahead and move on to some of the problems we're actually going to be solving it. And again, this isn't the only time that we're going to practice this today. So if you're not 100% confident on this, you'll see again, we're going to do this more. Okay, so these problems want you to solve the compound inequality and then graph the solution on the number line. So the first thing that you need to do is solve the individual inequalities separate. So if we're doing this, we've got 2x minus 2 is less than or equal to -8. Add 2, add 2. 2x is less than or equal to -6. Divide by 2, divide by 2. X is less than or equal to -3. Notice I did not reverse my sign because I divided by a +2. This -6 doesn't matter. We're dividing by a +2 on each side. So that's one side of our inequality. Now we've got the next one. So 2x plus 1 is greater than 11. -1, -1. So 2x is greater than 10, dividing by 2 on both sides would give us x is greater than 5. Now remember, this was an or. And so ors, we can think outside or. So if we're graphing this on the number line, we can't, first of all, we cannot write this with one variable. With ors, you have to have 2 variables. So then the second thing would be at 5, this is just a greater than. So at 5, we have an open circle. But at -3, notice that that's a less than or equal to. So at -3, we've got to have a closed circle. And then remember, or outside. So we should be shading here, and we should be shading outside down there. Okay, so that was an example of an or inequality, solving it, graphing. Okay, so let's look at this second problem. In the second problem, we're given an and inequality, and you don't see the word and, like I told you. So we need to break this into 2 inequalities. The way we do that is by keeping the center the same. Okay, so keep the center. We're always going to keep the center. Okay, so for the first inequality, we're going to use the left side. So -19 is less than or equal to 3x minus 4. And then remember, this is an and then keep the center. So you keep your 3x minus 4, but now the other inequality is just going to be written using the other side. So now we've got 2 inequalities. We can solve these. And remember, the solution we're looking for is the overlap of these 2 answers. So add 4, add 4. That gives us -15 is less than or equal to 3x. Dividing by 3, dividing by 3. Again, we're dividing by +3. So our sign doesn't change. We just have -5 is less than or equal to x. That's one side. Remember, this is and then we have to solve this other inequality. So add 4, add 4. So we get 3x equals, whoa, no, not equals 5. Whoa, mistake. -1 plus 4 is +3. And then divide by 3, divide by 3. And x is less than or equal to 1. Okay, so now we've got to put this back together. Okay, so yep, Isaiah, very good. Looks like some people are already getting this. But if we're putting this back together, the x stays in the middle. And then remember, if we use these less than signs, then all we have to do is put the lower number on the left, so -5 down here, and the higher number on the right, so +1 up here. And then we can just check, okay, well, x is less than or equal to 1. X is less than or equal to 1. Perfect. X is greater than or equal to 5. X is greater than or equal to 5. Perfect. Checked. Very good. And then closed circles for graphing it. Yes, very good. Kwamir, all from -5 all the way to 1. So we've got a closed circle at -5, closed circle at +1, and then we are shading in between. Awesome. Very good. So like I said, I think that this part can be kind of tricky, but if you can remember the left hand less than trick, I think that makes it a lot easier. And then lower to higher, it's a little bit easier. All right. So I think you guys, again, getting pretty good with this. A lot of these things have been just, things that we've already done in the past. So there was the one new thing with adding the ands and the ors. But let's go ahead and see if you can actually do this on your own now. So here's your exit ticket for today. What you need to do is you need to send me your solution only using the variable one time. So that variable should be sandwiched in between 2 inequality signs. All right. And then once you have sent me your answer and I have told you that it is correct, then you are good to go, done for today's lecture.